information today. And guys, honestly, what I'm going to show you today is useful, but ultimately pretty much everything I'm going to show you, you can do with the calculator. Okay. So is it useful? Yeah. Can you use this at times? Sure. Is there a question on the quiz that I'm going to give you that'll use some of these techniques? Absolutely. But ultimately, you should be able to do everything and get all the answers that you're going to provide with the calculator. Okay. So here's what we have. We have this. All right. And what I want to do is I want to use the technique of completing the square, bless you, to answer this. I want to use the technique of completing the square to answer this question. Now, if you remember the technique of completing the square, congratulations, you're bionic, like me. If you don't remember it, let's go through it. The first thing you need to do is you only want x's on one side. So I'm going to take this 18 and I'm going to move it over here with the y. Now, I know that seems counterintuitive to what you normally do, right? It's a little strange. That's okay. And then what you're going to do is this. You're going to look at your a term, bless you, and your b term, right? Which of those is the a? The squared, the number before the square, right? So what's that number? It's 1. So a is 1. And what's the b term? Give me the sign. -8. Okay. So if you remember this technique, what you're going to do is you're going to take half of the b. You're going to square it. You're going to add it to both sides. So you're going to take half of the b. You're going to square it, and you're going to add it to both sides. Bless you. So the b term was -8. Half of -8 is -4. And what is -4 squared? +16. All right. So I'm going to add 16 to both sides of this equation now. Okay. So I have y minus 18 plus 16 equals x squared minus 8x plus 16. I feel like I need more room. Let me do this. I'm going to move this over here. Give me a second. All right, so that was a, yep, I gotta put that back. All right, so adding that to both sides is going to give me y minus 18 plus 16 equals x squared minus 8x plus 16. Okay, guys, this is a guaranteed, no doubt about it, going to happen. The right-hand side of this is going to become factorable. Guaranteed. So I need two numbers that multiply to be 16 that add to be -8. -4 and -4. So I have y minus 2 equals x minus 4 times x minus 4. Guys, what's another way to write x minus 4 times x minus 4? X minus 4 squared. All right, last thing I'm going to do now, guys, is I'm going to put this 2 back over here. Right, so I'm going to take this -2, I'm going to put it back over here. And I get that. Now we're going to do another example of this in a minute. okay? But what I created was something known as vertex form. Please do me a favor. That is vertex form. Now, let's go to my graph and let's see how this correlates to what the vertex actually is, okay? So I'm going to graph this. Again, I said that all of this can be done on the graph, right? So do we really need to know vertex form if I can get the vertex from the graph? Probably not, but nonetheless, we're going to need to be able to do it. All right, so in my calculator, guys, x squared minus 8x plus 18. Gives me this, okay? The vertex is right here, correct? How do I find it? This is, guys, you got to be able to do this. This is a guaranteed need to be able to find the vertex. So how do I find this value, this low point? I go to menu, analyze, and what am I looking for? It's not a 0. Minimum, yeah, I want this low point on my graph, right? So remember, this is where you create that shaded zone, and there's my minimum, right? So my vertex is 4, 2. All right, so let's go back to this question for a minute. My vertex is 4, 2. So do we see the relationship between this and this? It's kind of weird. It's kind of weird. But what is the vertex? It's the opposite sign of this, and it's the actual sign of that. So 4, 2. So if I gave you something like this, guys, ready, watch. Right? If I gave you this in vertex form, what would you consider the vertex to be? -3, -4. Yep, so it's the opposite sign of this and the actual sign of that. Okay? You guys actually did some work with shifting things in your algebra classes, right? So this was a parabola that was shifted to the left 3 and down 4. Let's write that down. Actually, not for this one. This was a parabola that was shifted. So we said what? Shifted to the right 4 and shifted up 2, right? So it's always the opposite of this sign and the actual of that sign. All right, we answered part C, right? We already answered part C. Is that okay? Now we're going to do another one now. All right, bless you. Going to do another one now, okay? A little bit more complex. All right, so guys, our first step. So step number 1, so I'm going to write some steps down here, okay? Step number 1 is to get all x's on one side. Get all the x's on one side. So what do I need to do here? Add 2 to both sides. Very good. Add 2 to both sides. And so that's going to give me a y plus 2 equals 3x squared plus 12x. All right, guys, this one's a little bit different from the last one, okay? This one's a little bit different. How is this one different when you look at this as opposed to the previous one? Yeah, you can already factor it. I agree with that. You know how on the last one I just had an x squared? Here I have a what? A 3x squared. Now here's the thing, guys. In order to use complete the square, this has to be a 1x squared, not a 3. So what I'm going to do is you agree that I can take a 3 out of both of these. All right. Now, it's not a greatest common factor. I'm just taking a factor of 3 out because I want this to be an x squared still. I agree, guys, that I could take an x out of both. So I'm not taking a greatest common factor. I just want this term to be a 1x squared. So if I take 3 out of both, I can accomplish that, right? Okay, so I'm going to do that. Everybody okay with what I just did? I just took 3 out of both of those terms. So here's what's going to happen now. This is my b term, right? And I said, actually, let's write this down. My second step was to what? Make sure the x squared term has a coefficient of 1. Make sure the x squared term has a coefficient of 1. All right, so I have that. All right, so now my third step is going to be to add b squared over 2. So what's my b term right now? It's 4, right? So I have 4 divided by 2 squared. What's 4 divided by 2? 2. What's 2 squared? 4. Now watch, because this is where I'm going to mess you up. I'm going to add 4 here. Now, I said before that I'm going to add b over 2 squared to both sides, right? Watch. When this 4 is sitting here, what's being done to this 4? It's being multiplied by 3. So when this 4 goes here, I didn't add 4. I really added what? 12. So if this 4 goes here, I got to make sure that I add 3 times 4 to this side. And we're going to see that in the next example as well, okay? I added 3 times 4. Now, my next step is going to be to factor. Well, what does this left-hand side become? I have y plus 2 plus 3 times 4. So I have y plus 12 plus 2 is what? 14, right? Equals 3 times. All right, factor. 2 numbers that multiply to be 4 that add to be 4. 2 and 2. Guess what? Those numbers are always going to be the same. Always. After you factor, you're then going to rewrite the equation. How can I rewrite this equation, guys? What's x plus 2 times x plus 2 the same as? X plus 2 to the second power. So I have 3 times x plus 2 squared. Oops, sorry, that's wrong. There we go. Now, I said that I wanted to say y equals, right? So what do I need to do with this 14? Subtract it, right? So I got to move it to the other side. So is everybody okay with this becoming that? Cool? All right. This is now in vertex form. This is a graph that's been shifted to the left 2 and down 14 because of that. So again, I know it's weird. It's always the opposite of this, but we keep that the same. Left 2, down 14. What did I call this, guys? I called this vertex form. All right, let's do another one. All right, same technique. All right, same technique. So what again was my first step, guys? Move over the 1, right? Move the 1 over. Okay, so I have y minus 1 equals 2x squared plus 6x, right? Now remember, I can't use this technique unless my x squared term is a what? Is a 1. So what do I need to take out of this to make this a 1? All right, so I'm going to have y minus 1 equals 2 times x squared plus what? 3x. This one's going to freak you out a little bit, okay? Relax. Don't get too nervous. Everybody okay with what I'm doing right there? Okay, so now I know I need to add half of my b squared. This is going to make you nervous. What's my b value? So I have 3 over 2 squared. What do we not like about this? It's a fraction. But guys, what's 3 squared? No. Listen to my question. What's 3 squared? 9. What's 2 squared? 4. So this is equal to 9 over 4, right? Right? 3 squared is 9. 2 squared is 4. It's 9 fourths. So I'm going to add 9 fourths. Everybody cool with where that came from? Now, guys, in that previous example, when I added this 4, what did I say? I'm really not adding 4. I'm adding 4 times 3, right? So what am I really adding here? I'm adding 9 fourths times 2. So I need to add that to both sides. So I already did it to the one side. Now it's here. All right, now, guys, now it's just a matter of being able to use your calculator, okay? So what do I have? I want to combine -1 plus 9 fourths times 2. -1 plus 9 fourths times 2 gives me 7 halves. All right, so this left side becomes y plus 7 halves equals 2 times. Okay, now, how's he going to look at this? He's going to say, Picardo is not going to ask me for 2 numbers that multiply to be this and add to be that. Like, you're really not going to ask me that. But I'm going to show you a trick. Want to see a trick? I'm going to go all the way back to this first problem that we did. Blake, this is huge. Check this out. That was what that factored into, right? I want you to notice something. What was -8 divided? Where did I get -8 from? I got that from where? From right here, right? What was half of -8? It was what? It was -4, right? What number do you notice both of these numbers are? -4. That was half of my b, right? Okay, now look at the problem that we just did a second ago. I added what? I got, actually, let me do this in a different color. I had +2 and +2, right? What was my b term in this case? 4. What was 4 divided by 2? So do you notice that the number that is creating the factors is always half of the b? So in this case, the b value was 3, right? So what was half of the 3? It was 3 over 2. So the number that I'm going to use is 3 over 2. Now, Sean, check it out. These numbers are 2 numbers that multiply to be 9 fourths. Do you agree that 3 over 2 times 3 over 2 is 9 fourths? And Sean, what's 3 halves plus 3 halves? 3 halves plus 3 halves is 6 halves, right? What's 6 halves the same as? 3. And that's what we wanted them to add up to be, right? So it works. Okay. Cool? What, guys, what's 3 halves times 3 halves? How do you add fractions? You keep the denominator and you add the numerator, right? What's 6 divided by 2? 3, right? So it's two numbers that add to be 3 that multiply to be 9/4. All right. Again, with a calculator, I don't really care if you can add and subtract those numbers anyways. Guys, what's x plus 3 halves times x plus 3 halves the same as? X plus 3 halves what? Squared. All right, and then my last step is just to take this thing and move it to the other side, right? So it's y equals 2 times x plus 3 halves squared minus 7 halves. So in this case, this would be a parabola that was shifted to the, which way? Left 3 halves. And what? Down 7 halves. Now, Sean, you said it a second ago. What's 3 halves the same as? No. What's 3, Sean, what's 3 halves the same as? You gave me this a minute ago. 1.5. So if I go left 1.5, my vertex is at negative 1.5. And if I go down 7 halves, what's 7 halves the same as? 3.5. Negative 3.5. So this is where the vertex would be for this parabola. Now again, what did I say? This scale is kind of what? Weird, not weird, but pointless, because what can you do? You can use your calculator to accomplish the exact same task way easier, way simpler. But you need to be able to do it. I mean, it's a skill that here's the thing. There are about a dozen skills that we're going to do this year that I think are totally, utterly useless because you have the technology. But it doesn't, I don't get to be the god of what the curriculum the state requires. So if I were the god of it, I would no longer make you do this, but I'm not. Someday, if I ever am, I'll eliminate this completely, I promise. Yeah. Until that day. Did you say I might be dead? Oh, you might be dead. Okay. All right. Good. As long as I'm not. All right. So here's what we're going to do. All right. I'm going to now give you a question, right, of something that I could see show up on an exam. Okay. So here I give you this weird looking thing. Don't even look at this. Okay. This right here is just a really, really cool, simple way of doing what we just did. Okay. So I'm going to find the turning point using this. Okay. Guys, who took algebra last year? Okay. When I say vertex, right? When I say vertex, and this is what you're doing up here. Remember, the vertex is nothing more than what? Here's my parabola. Here's my vertex, right? If I asked you guys to give me a piece of information, what would you say? It's the turning point. And the turning point always lies on what? The axis of symmetry. So don't you already know the x value of that because you can find an axis of symmetry? The axis of symmetry was found using the formula negative b over 2a. So in this example, what's my a value? 1. What's my b value? 10. So if I asked you guys to find the axis of symmetry, it would be negative 10 over 2 times 1, which is what? Negative 5. So you know the axis of symmetry is at negative 5, right? How do you get the other value? Plug it into what? Plug it into this, right? because I want the y value where x equals -5, right? So now the y value can be found by taking this and plugging it in for x, right? So that's going to give me 25 minus 50 minus 2. That's -27. Okay. So this parabola has a turning point of -5, comma, -27. Guys, I think that's easier than this whole thing that I showed you, right? So that's another way to get your vertex. Now, using completing the square, which you need to be able to do, if I did it the other way, what would I have to do? Give me my first step. Move the -2 over. So what does this become? Y plus 2 equals x squared plus 10x. Why is this problem a little bit easier? Because the x squared term is 1. So all I have to do now is what? Add half of the b squared. Well, what's the b term? 10. What's half of 10? 5. So I'm adding 25, right? Do you see how this problem's different? I didn't factor anything out of this, right? So I just added 25. So I have to add 25 to the other side. I didn't take anything out to begin with, so I'm good. Plus 25. So what is this going to now say? It's going to say y plus 27 equals. Okay, can I factor this? Yeah, and remember, guys, the trick is that it's always going to factor into two numbers that are always the same as this, right? So it's going to be x plus 5 times x plus 5. Always going to be true. What's another way to write that? X plus 5 squared. So I have y plus 27 equals x plus 5 squared. And then my last step is to take this 27 and move it to the other side. So I have y equals x plus 5 squared minus 27, which is a parabola that's been shifted to the left 5 and down 27, which gives me -5, -27. It's always going to be, if this is positive, it's going left. If this is negative, it's going right. If this is negative, it's going down. If this is positive, it's going up. So it's weird, right? You got to memorize this, guys. This is one of those things that you got to memorize. This is always going to be the opposite sign. This is always going to be the same sign. Verify your answers. We already did that. All right. Last example of the class. I have f of x equals 2x squared minus 12x plus 7. This says use your formula x equals -b over 2a to find the turning point. Guys, I know you can do that. Let's make sure we can do it the other way. Let's make sure we can do it the other way. So what are we going to change f of x to be? Y. What am I going to do with the 7? Subtract it. So I have y minus 7 equals 2x squared minus 12x. Now remember, I can't use this technique unless my x squared is a what? 1x squared. So what do I need to do here? Take out a 2. All right, so I did that. Now, I know I'm supposed to add half of the b squared. What is my b term right now? -6. Half of -6 is -3 squared, which is 9. So I'm adding 9. But hang on, guys. I didn't really add 9. I really added 9 times 2. So what does the left-hand side become? It's y minus 7 plus 18, y plus 11, equals 2 times what? Now I got to factor this. And remember the trick. It's always going to be whatever this is. So what is it? X minus 3 times x minus 3. What's another way to write that? And then my last step is to simply take the 11 and put it back where it belongs, right? And that is my vertex form of the parabola. Now, Trinity, remember that if I asked you to give me the vertex, I got to do something special with these signs, right? So what is the actual vertex? To the right 3, down 11. So you're going to leave it like this. This is the form. So then I would say, so in this case, it's not to the left, it's to the right 3 and down 11. So this sign always stays, this always tells me the right thing to do. This always tells me the opposite of what I'm supposed to do, right? So this is right 3, down 11. Right 3, down 11. That's my vertex. Okay. Now, guys, you have some bags, you have some, I'm trying to think of the right phrase here. You have some tools in your bag of tricks. You have completing the square. You also have that negative b over 2a, right? So on a problem like this, you can really choose which method you want to use, unless I tell you to do it a specific way, correct? So if you look at your quiz, which I'm about to hand out to you now, okay, there are a couple of questions. That I want to point out. I'm going to tell you exactly where to look in the notes for each of these questions, okay? So when I hand this to you, don't do anything with it. Yeah. All right. So, ready? That first problem, quadratic inequality. Write that down. Quadratic inequality. There is a lesson from this unit that says quadratic inequalities. Okay. Problem number 2 and 3, you can't do yet. You'll be able to do them after our lesson tomorrow. Question number 4 is exactly what we just did in class. I give you it in vertex form. Tell me what the vertex is. Question number 5 is exactly what we just did in class. All right, so it's on that lesson. Question number 6. You're not going to be able to do question number 6 until after the next lesson. So wait on that problem until after tomorrow. Question number 7 is a quadratic inequality. So go to the lesson on quadratic inequalities for any clarification on question number 7. And question number 8 is exactly what we just did in class. So you can use today's lesson for question number 8. And Jelani, yes, you have to use the completing the square process to do that one. Okay? You got to show the work, what we just did. Okay. This, say again? Yes, so this, guys, this quiz is due when again? Friday, okay? You also have a problem set, which is due tomorrow, right? And you're turning in zero product law, you're turning in quadratic inequalities, you're turning in the complete the square assignment, okay? So those three